everyone, and welcome to the next lesson of exponents, where we will look at some of the exponent laws, and I also included 3 of the definitions again. Now, when we start with the first law, it just simply says that when we multiply same bases, and I always believe that the exponent laws are made for letters that are raised to exponents, okay? Because if we have, for example, a 2 to the power of 3 times 2 to the power of 2, we can simply say that it's 8 times 4 and it gives us 32. We could also say, because these two bases are the same, we simply write the 2 and then we add the 2 exponents, the 3 plus the 2, and it gives us 5, which in the end gives us 32 as well. But why go through all of that if you simply know that 2 to the power of 3 is 8, 2 to the power of 2 is 4, and it's in line with BODMAS because powers and roots come before multiplication, right? So I believe the exponent laws helps us to multiply the same letters with the same letters. What do? We simply write that letter and we add the exponents. When we divide the same letters with the same letters that have exponents, we simply write the letter and we minus the exponents. When we have letters inside brackets that have exponents, we simply write the letter and we multiply the exponent on the inside with the exponent on the outside. So we simply multiply those two, okay? And then for our fourth one, if we have more than one letter on the inside, we simply write the A, we write the B, and then don't forget, there is an exponent 1, so it's 1 times n, right? And there's also an exponent 1, so it's 1 times n. That's why it will be a to the power of n and b to the power of n. Because every base on the inside, we simply write that letter and we take its exponent, multiply it with the exponent on the outside, and we get the new exponent. We write the next base down and we take its exponent and we multiply it with the exponent on the outside. Okay. Similarly, we can say when there's brackets on the or a fraction on the inside of brackets and it's raised to a certain exponent, well, that exponent is positive, so we simply just want to multiply it in. So this is a to the power of 1 and we multiply it with n, which gives us a to the power of n. And then this is b to the power of 1 and we simply multiply that 1 with n, which gives us n, because 1 times n is n, right? So we will have b to the power of n. Now, then that leads us to our 3 other definitions which we looked at in the previous lesson. So any base to the power of 0 gives us 1. And remember, a can never be a 0 then. And then a to the power of negative n, we simply take that base that has a negative exponent, we pluck it out, we go put it below the line. You remember that? And then if we have a fraction inside brackets, please remember this, and it's got a negative exponent on the outside. We first swap this fraction around, and then the negative exponent becomes positive, and from there we can apply this law again. So it will be b, and then it will be 1 times n, which will be a n, and at the bottom we will have a to the power of 1 times n, which gives us a to the power of n. Okay, great. See the difference here? Because we started off with a over b in brackets to the power of a negative n. And then to get rid of that negative exponent, we swap these two around. And then we simply follow the law number 4 here. So, quite easy, but you have to remember your laws as well as your definitions and all the different ones from our previous lesson, okay? Now, the math recipe simply says, when we simplify each term using BODMAS. Okay, so we want to find our terms and then we want to use BODMAS. And that leads to simplifying the overall sum. When we get to exponents, however, the laws of exponents are done in the order of the BODMAS steps. And some laws, like law 7, 5 and 6, or 5, 6 and 7, are done before any other to help make better sense of the sum or calculation. Now, I want to continue here with this paragraph there. And I want to say that you can either use these definitions in the beginning to make better sense of the sum or calculation. For example, if you have this, swap the 2 around, get rid of that negative exponent, then it makes that multiplication easier, right? Or you can simply just do the normal BODMAS. So this will basically become a to the power of negative n over b to the power of negative n. And then we simply have to, in the end, swap these two around because that base has a negative exponent and that base has a negative exponent, which gives me b to the power of n and at the bottom a to the power of n. See, we end up with exactly the same answer. So definitions can be done right in the beginning or right at the end, or maybe sometimes somewhere in the middle if we want to make better sense of the calculation. So please, lesson 1 and lesson 2 that we have done here for exponents simply help us list all the rules, all the things that you can do. So if you do things that's not part of these two lessons, well, you're following a certain rule that doesn't exist. So please make sure that you know the definitions and the laws from these two lessons. Now, here are some examples to help you remember the exponential laws. Now let's have a look. There's one term here, so we want to do BODMAS to solve the entire term. Okay, so are there brackets? No. Powers and roots that I can do? Well, there's powers, but I cannot do anything to them. Okay, so how about, is there division? No. Multiplication? Yes. Now how do we multiply? We always multiply our coefficients with our coefficients because numbers can always be multiplied with numbers. Now I'm talking about the coefficients, not the exponents, right? So 3 times 2, that gives us 6, and 6 times 5 gives us 30. So we are busy with the multiplication. Now when we multiply the same letters with the same letters, we simply write the a, and then what do we do with these exponents? We add them, not multiply them. So 2 plus 2 is 4 plus 2 is 6. And there we go. Our answer is 38 to the power of 6. So can you see? We don't have to apply any exponential laws to the numbers or the coefficients because we already know 3 times 2 times 5 is 30. We use these exponential laws and definitions and things to help us multiply, divide, raise letters to powers. Okay, so how about the next one? This is to catch you out. This is a bit of algebra. If we have 3x to the power of 2 plus 3x to the power of 2, it's exactly the same letter with the same exponent, same letter with the same exponent. So we're taking 3 of those plus 3 of those. It gives us 6 of those. Okay, so 6x to the power of 2. You remember this from your algebra, right? Because when we do adding, we have to add like terms, and these two are like terms. So I've got 3x to the power of 2's plus 3x to the power of 2's, which gives me 6x to the power of 2's. Now, how about this third example? Now, again, we've got only one term, so we can use BODMAS to solve it. So let's just quickly have a look. I'm going to apply my definition first because there's a base that has a negative exponent. So I can take this entire base and I can move it to the top. So let's quickly do that. This will be 6a to the power of 4. Then the bottom a comes to the top and it will become a positive 4 as well, right? Because a to the power of negative 4, if I move it to the top, that negative 4 will become a positive 4. And what remains at the bottom? Only the 12. Now, our step here is we don't want to start dividing yet because we want to simplify this numerator first. I always simplify my numerators as far as possible. So this will simply be a 6a to the power of 8 divided by 12. And then the rest of this is quite easy because now we simply have division. And then we can say 6 goes into itself once, it goes into 12 2 times. And therefore we are left with 1a to the power of 8 over 2, which is the same as a half a to the power of 8. It's exactly the same answer, so it doesn't matter which one of those two you end up with. The thing that you have to remember here is keep simplifying your numerator and your denominators as far as possible before you start doing the division. Okay, now I'm going to draw a line here down the middle quickly, just like this, and I'm going to show you that there was another way to do this, that we didn't have to use the definition. I told you we can use definitions in the beginning by moving it, or we can simply start with BODMAS. Now let's have a look at this. So are there any brackets? No. Powers and roots I can do? No. Division? Yes. So 6 divided by 12 is a half, right? Okay, now how about this? if we divide the same letters with the same letters, we simply write the letter. So I write the A, and then it will be the top one minus the bottom one. So it will be 4 minus a minus 4. So I'm going to write this. So 4 minus a minus 4, which simply becomes 4 plus 4, right? So then I have a half. A to the power of 4 plus 4 is 8, and I end up with exactly the same answer. Okay, so we can either use definitions to change the way it looks to help us do the calculation, or we can simply do BODMAS, and if this ended up being a -8, we simply apply the definition right at the end. But in this case, it was not necessary. Now let's go and look at some more examples. Now here are some examples that you can try, but I'm going to go quite quickly through them, so try them at home once you already resume the video to see if you are correct. Now there's only one term, there's no brackets, no powers and roots I can do, but there's division. Now I'm going to do the cancellation here, and I always start same letter with same letter, so the A's with the A's, the B's with the B's, the C's with the C's, and I go and find the A that has the smallest exponent, which will be A to the power of 6. So if I take 6 A's away there, I have to take 6 A's away here, and how many A's will remain at the bottom? Only 2, right? So please don't forget, this is what I do. I draw my line in, and as I cancel them out, I always write them in their appropriate place, the ones that remain. So see, A to the power of 6, I take 6 away there. If I take 6 away from the 8, 2 remains, because remember, division for letters means minusing the exponents, right? So I take all 6 away there, I take 6 away at the bottom, 2 remains at the bottom, so A to the power of 2. Here, there's B to the power of 2, B to the power of 4, so I take 2 B's away here. If I take 2 away from the bottom, I need to take away 2 at the top, so I've got B to the power of 2 left at the top. So let's write that down. Now here I have C to the power of 1 and C to the power of 2. So I take a C to the power of 1 away there. If I take 1 at the top, I need to take 1 at the bottom, and 2 minus 1 is a 1. And I've got C to the power of 1 at the bottom. And I am done. And you don't have to write that 1. You can if you want to, but it doesn't matter, because all bases, if I can see the exponent, it is an exponent 1. How about this example over here? Everything in the brackets belong to the power of 3. So, signs to the power of 3. So, minus, minus, minus is a minus. And 4 to the power of 3, that is an integer or a coefficient. So, 4 to the power of 3 is 64. And what do we do with letters? We simply write that letter, we write the A, and then we take the exponent times the exponent on the outside, and 2 times 3 is 6. Okay, so far so good. How about the next one? There are brackets, but nothing I can do inside that bracket. Please forget about everything else. If we go through BODMAS, I'll write it here at the side. If we go through BODMAS, the B simply means look inside the brackets and see if there is BODMAS to do on the inside of the brackets. Well, nothing. It's just an A to the power of 2. There's just an A to the power of 3, so nothing I can do there. So there is no B. Are there powers? Yes, there's powers that I can do, because it's A to the power of 2 in brackets to the power of 3. So that means write the A, and then we say 2 times 3, which will be a 6, and we still multiply with 3 at the front here, which will give us 3A to the power of 6. Times, and this will be a 2A, 3 times 2 is 6, and I'm just going to leave out the brackets, because A to the power of 6 times 2 is 2A to the power of 6, right? And now we've done the powers and roots, there's no division. How about multiplication? How do we multiply? We take the coefficients and multiply with the coefficients, so 3 times 2 is 6, same letters with same letters, write the A, and then we say 6 plus 6, which gives us to the power of 12. Okay, brilliant. Now, next example. Now it's getting a bit more complicated, but we start off with BODMAS and see how easy my recipe makes it for you, because there's only one term here. we start with the B for BOTMAS, which means look inside the brackets and see if there's anything to do. Well, there is. There's a fraction on the inside, so I have to simplify the numerator as far as possible, the denominator as far as possible. So this will end up to be, now that is a multiplication, so 2 times 3 is 6. And then we write the a, and then we simply say 3 plus 2, right? Because we're multiplying that a with that a. We write the a, 3 plus 2 is to the power of 5. And at the bottom, we simply say a, we write the a, and then it will be 3 times 2, which gives us a 6. And we multiply it with the 6 at the front, which gives us a 6 as well. And we leave all the other things the same. So I've done the B, everything on the inside of the brackets. Are there still anything I can do on the inside? Yes, I can still divide, so I'm still busy with the B. So basically this means that 6 divided by that 6 cancels out, so it's only a 1. And then there's a to the power of 5. If I take a to the power of 5 there, I take 5 at the bottom as well, and only a 1 remains. So this is what is left on the inside of the brackets. Okay, only a 1 over a to the power of 1. And we put that in brackets to the power of 2. And now we are simply done with the B finally. Are there any powers? Yes. So everything in the brackets to the power of 2, 1 to the power of 2 is a 1, and a to the power of 2. What do we do with letters? We simply write that letter. That 1 times 2 gives us 2, and that is my answer. Please don't go and write that it's just an a to the power of 2. This is a fraction. If you just write a to the power of 2, it means that it is now a whole number and not a fraction anymore, right? Okay. So how about the next example? Again, we have only one term, but this is a division or a fraction. So we have to simplify the numerator as far as possible and the denominator. We can also use definitions to change the way that it looks. But I'm not going to do that at the moment. I'm just going to follow my BOTMAS. Okay, so this will just be the following. If I just look at the top and the bottom here, I ask myself, are there any brackets I can do? Well, nothing inside those brackets, nothing inside those brackets, nothing inside those brackets. So the B for BOTMAS, and I'll write that again just to show you how my steps work. There's no calculation inside brackets. Are there powers? Well, there's powers that I have to do there with everything on the inside, there with everything on the inside, as well as there. So let's do that. So this will simply be, write the a, minus 2 times minus 3 is a positive 6, because minus 2 times minus 3 is positive 6. And then we simply write the b, and 2 times minus 3 is a minus 6. Then multiplied by, because I'm still busy with powers, so write the a, and then it's that 1 times the minus 6 gives us minus 6. Write the b, and that 1 times the minus 6, also minus 6. And then don't forget about the 6 on the outside, so it just stays there because we already did that powers. And then once we're done, we multiply it with the 6 there, so it's 6a to the power of 6b to the power of negative 6. And at the bottom, we have the following. That is basically everything in the brackets to the power of 2. So 2 to the power of 2 gives me a 4. We write the b, and then it's minus 6 times 2, which is a minus 12. Okay, looking a bit better. So this becomes the following. At the top, we've got multiplication because we've done the powers. Now, we don't want to divide yet because I still can multiply the things here in the numerator. Remember, simplify your numerators and denominators as far as possible. So 6 times 1, it stays a 6. And then a's with a's. A and a, write the a. 6 plus minus 6 is a to the power of 0. So let me write that down. And then write the b, and then this will be b to the power of minus 6 and b to the power of minus 6. Write the b, minus 6 plus minus 6, which gives us a minus 12. You can test that. And then at the bottom, we've got a 4b to the power of negative 12. Well, same thing here, same thing there, cancels out. And remember what happens with a to the power of 0, it becomes a 1, right? So now we basically have left, as we keep on cancelling, 2 goes into 4 2 times, it goes into 6 3 times, and a to the power of 0 becomes a 1. So it's basically 3 times 1, which will be a 3 over 2, and my answer is 1.5 or 3 over 2. And that is all there is to it. So you just have to keep your head about yourself, and please remember, you don't have to do the definitions. The BOTMAS are way more important, and once you end up with something negative in your final answer, you can apply a definition. You could also have just taken this ab to the power of -6, put it below the line, and it will be a +6, and continue just to do the multiplication and the powers at the bottom, right? Okay, so don't forget all these steps. Keep practicing them. They are quite important. Work through this video again. Practice them again until you end up with the final answers. And play around with the definitions by changing them in the beginning and see if you get the same answer. And just using BOTMAS and see if you get the same answer. Okay, I hope to see you again soon. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.